Assalamualaikum and hi everyone. My name is Nur Adrena from Terabi. Today I will be talking about analysis of current issues, which is daily phone usage. We all use our phones a lot, but sometimes we don't realize how much it can impact us physically and mentally. So let's dive into it. From article from Astro Awani, according to the National Health and Mobility Survey on 2019, almost 80% of Malaysians use smartphone for more than 6 hours a day. This prolonged usage contributes to physical issues like neck, shoulder, and finger pain. Also disrupts sleep pattern, which is leading to stress. Smartphones are super useful. They could help us stay connected, work, study, and chill. But when we use them too much, it can lead us to problems like body pain, sleep issues, and even stress. That's why we choose this topic to raise awareness and share what we found about the data. The rapid increase in daily smartphone usage, with many individuals spending more than 6 hours per day on their devices, has raised concern about its negative effect. Prolonged usage not only impacts physical health, such as neck, shoulder, and finger pain, but also affect on sleep quality, mental well-being, and overall productivity. Without proper awareness and preventive measures, excessive phone use may lead to long-term health and social issues. To understand the issue locally, we gathered all data from our close friends and close family. Our goal is to assess how daily phone usage affect working adults in our community. This grassroots approach helps us connect national trends to real-life experience. So first, our study focused on Malaysian citizens to reflect national relevance. The second one, Selangor residents as our sample because due to its urban density and technology engagement. While our variable, we got three. The first one is adult, male, and employee. Adult male as a primary user for work and communication, while employees whose screen time is often work-related. This sample helps us analyze usage pattern and health outcome in a high-risk demographic.
To begin our analysis, we organize the raw data into frequency table. This helps us identify how often certain usage duration occurred. We then visualize the data using a histogram which clearly show the distribution of smartphone usage across different times intervals. We also include a GIF or cumulative frequency graph to observe how usage accumulates over time. This is useful for identifying percentiles, for example, how many users fall below a certain usage threshold. These visual tools make it easier to interpret the data and spot patterns, such as whether usage is skewed toward higher or lower durations. Next, we perform statistical analysis on the n-group data. This means we use the raw values directly without grouping them into intervals. Here's are the results. So for the mean, we've got 264.32 minutes. It's the average usage of time. For median, we've got 232 and 50 minutes. It's the middle value when the data is sorted. For the mode, we've got 51 minutes. It's the most frequently reported usage of time. For variance, we've got 22,000, 9 and 8800.99, and this tells us how spread the data is. For standard deviation, we've got 151.62. It's the average distance from the mean. So the height standard deviation and variance show that usage varies widely among individuals. Some use their phones moderately, while others spend several hours daily. So here we analyze the raw data without grouping it into intervals. This method gives us more detailed look on individual usage patterns. We calculated five key statistics. So for mean, we've got 264.32 minutes. This is the average usage time. For median, we've got 232.50 minutes. It's the middle value showing that half of the respondents use their phones for less than this amount. For mode, we've got 51 minutes. It's the most frequently reported usage time, which might reflect a small group of light users. For variance, we've got 22,988 and 99. This tells us how spread out the data is. So for standard deviation, we've got 151.62. The meaning most users are within plus or minus 152 minutes of the average. These results shows a wide range of smartphone usage from very light to very heavy. It suggests that while some individuals are moderate users, others spend a significant portion of their day on their phones.
6.1 Frequency Table. This table shows the group data for daily smartphone use in minutes based on our mark study, lower and upper. This column shows the class interval which is 51 to 100 minute, 101 to 150 minute, and so on. Frequency, number of respondents who use phone in each class. For example, 17 people was there, point between 50 to 100 minutes. Midpoint, the average of the lower and upper class limit used in further class calculation. Fx, frequency equal to midpoint, help calculate the mean. X square and Fx square. Sx x square is midpoint square and Fx square is frequency multiply midpoint square. This used to calculate the variance and standard deviation. LB and UB, lower and upper boundaries used for median and mode calculation. CF, cumulative frequency, running total of frequency, help use located the mean.
6.1 Frequency Table. In group data analysis, we calculate several key measures. For mean, 303.5, the average value obtained by multiplying the class midpoint with its frequency and dividing by the total frequency. Median, 330, the middle value of the data found using the formula based on the position in the cumulative frequency. Mode 317.33, the most frequent value determined from the class with the highest frequency. Variant 19,760 show how far the data values spread out from the mean. Standard deviation 114.41, the square root of variance indicating how disparate the data is. 6.1 Frequency Table. For median, LB, lower boundary equal to 300.5, the lower boundary of the median class. Fn, frequency of median class equal to 8. Fb, cumulative frequency before median class equal to 48. C, class size equal to 50. For mode, a lower boundary of model class equal to 350.5. D1, difference between model class frequency and the class before equal to -5. D2, difference between model class frequency and the class after equal to -7. C, class size equal to 50.
6.2 histogram. This diagram displays the distribution of data value across interval ranging from 50.5 to 550.5. The y-axis represents frequency indicating how many data points fall within each interval. As we can see, the model class is 5350.5 until 400.5 with the highest frequency of 15. This tells us that the most common data value fall within this range. The mode calculated as 390.5 gives us a more precise estimate of where the peak occurs. The histogram also shows a right-wide skew indicating the highest values are more frequent in this dataset. Seed point tree or GIF. An OGIF is a line graph that shows the cumulative frequency of a dataset. It helps us understand how data accumulates across intervals and is especially useful for identifying medians, percentiles, and distribution trends. This OGIF graph shows how data accumulates across intervals. The median value marked at 310.5 tells us that half of the observation fall below this point. The shape of the curve helps us visualize the distribution, whether it's skew, concentrate, and seed point tree or GIF. An OGIF is a line graph that shows 9.0 finding ungroup data. Data is shown one by one row or original value. No lower and upper, only value and their frequency. Easier for small dataset but messy for large data. Example, value 5, frequency equal to 2, value 7, frequency equal to 3. Group data. Data is organized into class intervals range. Use lower and upper to mark each class. Easier for large dataset, clear to analyze. Example, class 1 until 10 frequency equal to 4. Class 11 until 20 frequency equal to 7. 10.0 conclusion. The survey of 100 respondents shows a wide gap in daily mobile phone use, ranging from 2 to 20 hours. This indicates that while some limit usage to essential, others are highly dependent on their phone for work, social media, gaming, or entertainment. Such variation may be shaped by age, job, lifestyle, or personal needs, and raises concern about its effect on productivity, mental health, and overall well-being. 10.0 conclusion. That's all for us. Thanks for listening. Bye.